Welcome to Chapter 3. Up until this point, we've been playing in the fantasy land of CAD, where anything is possible. But it's time to talk about reality. We're going to go over DFM, or Design for Manufacturing. In Lesson 1, we're going to talk about how DFM affects your designs. So let's get into it. One of the most common terms that you're going to hear in manufacturing is DFM, or Design for Manufacturing. Now on the surface level, that just sounds like, can you manufacture the part or not? But there's a lot more to it going on behind the scenes. So let's come over here to the board. DFM is essentially just building out a checklist on how you should be designing your part. And one of the first things that we're going to go over on that checklist is efficiency. Now, the idea of this is just, can I reduce the amount of steps to make that part to make it a little bit more efficient, cost effective, that kind of thing. So with the idea of setups, can I reduce the amount of times that I need to manually manipulate this part, maybe take a hole out of the design that I don't need to flip the part over, that allows me to make it a little bit faster. This just makes it easier, essentially the same idea. The next thing on my checklist is it actually manufacturable? Can I actually physically make this part? Now, a great example of that is that I can, in CAD, in that fantasy world that we've been working in, is I can design a cube that has a sphere inside that cube. Now, in the reality of the real world, I can't make that part. And what we can do is 3D print it, right? But that breaks a lot of rules. So in the manufacturing side, we have to make some changes to our design and change the DFM side of it. What I could do is break that part into 3 pieces. I can make a bottom with a lid and a sphere inside of it, and then manufacture that part. So we always want to be working in a world that we can make. The next one is cost effectiveness. There's a couple different aspects of this. One example is am I picking the right material? Do I need to have stainless steel, or can I get away with aluminum? Stainless steel is a much more expensive material. So what do I actually need for my design? From a manufacturing side of idea, what we end up having is extra tight tolerances can increase costs. Right, so if I'm asking for a component to be made to 0.00005 thou tolerance, what ends up happening is I have to have a specialty machining and work holding in order able to make that part, and that increases the cost as well. Really what we're talking about is working in the real world, or in reality. And reality kind of comes from material plus the machine. What material are we using and what machine are we going to cut it on brings us back to what we're actually going to design around. Now, a material can dictate the machine, say aluminum versus carbon fiber. On aluminum, I can laser cut it. On carbon fiber, I can't. I have to CNC router it or waterjet it. And that changes the machine that I'm using, which changes the DFM in the background, which brings us back to that reality. So now that we actually have an overview of what DFM is, in the next lesson, we're going to start going over materials and how to pick it so we can start working towards that good DFM. So we'll see you on the next one.